My name is Ian Stocks. I'm a taxonomic entomologist with the Florida Department of Agriculture and Consumer Services, Division of Plant Industry in Gainesville, Florida. The groups that I'm responsible for are the scales, mealybugs and their relatives, and the Allarodidae, which are the whiteflies. Okay, so does everyone have a Phenacoccus madeirensis on the? Okay, so does everyone have it mounted then? And we're on the low magnification 4x. Okay, so you get the orientation, anterior to posterior. The first couplet is going to break out species that have different numbers of antennal segments. So the first thing to do is get the antennal segment, the antennae, at least one of the antennae in focus, and then you can go up to 10x, and this will be appropriate for making a good count. So if we start from the head, the first section, okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's going to be on the first plate of the illustration. So the mealybug plate 1, the figure 1. And the thing that's important about this key step here is that it's this terminal segment here that has the subdivision. So that's not always going to be a very complete or very clear articulation. So you may kind of describe that as almost like a pseudo-articulation. But that's where the 9th segment is coming from. Okay. All right, so now that you've established that you've got 9 antennal segments, that's going to take you to key step number 2, which has the 2 taxa of Phenacoccus madeirensis and Mealybugs hirsutus. So the first one of these then is to count the number of cerari. So you can either count from the posterior, the anal lobe, down here, okay, or, and this does vary in convention in the literature, you can count from up here. Now, a common number for cerarius count is 17, and when an 18th is included, let's see if I can, it will be in this position here, as mentioned earlier by Greg. So what you can do then is in the 10x mode is you can maybe start from the anal lobe and systematically work your way up the body as you change the position using the adjustable stage and count. So 1, 2, and what you're looking for, if you compare with these images that I have for plate 1, is roughly every segmental change you want to look for a structure like this, okay? And one of the most important characters is going to be the conical seta there, okay, paired in this case, and if they're broken off, they're going to leave a large, clear, round hole, okay? So I've counted 4 there, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. In my slide, 16 is just above the eye here, right there. 17 is the next one along, and then 18 is at the very anterior margin of the head here. So we've established that there are 18 cerari. The contrasting one for the pink hibiscus mealybug, Mealybugs hirsutus, is going to be 6 or fewer. Okay, and those 6 will be restricted to the posterior end of the abdomen, so there won't be any on the thorax or head. So in this couplet here, if you see any on the head, it's not going to be a pink hibiscus mealybug. The next major character we want to look for is, yes, a venter with quinquolocular pore. So let's get an idea then for what these different pores are. here at 20x, these larger disc structures here that kind of look like wagon wheels, okay, with evenly distributed pale spots, are the multilocular pores, okay? Now there's another type that's relevant for this genus called a quinquelocular pore, and we're going to have to go up to 40x to find that. And let me see if I can adjust the lighting a little bit. Trilocular pores are the most common and widely distributed pore type on mealybugs. The thing that's most important about the trilocular pore is where its distribution is relative to the Cerarium seedii. So usually a Cerarius will be defined as the presence of those modified conical seedii, the Cerarian seta, and the presence of a cluster of the trilocular pores. There are some genera with species where the number of those trilocular pores is important for discriminating between species. But this character here, we see in this one, we have a multilocular pore here, and then just to the side of it, a quinquelocular pore right there. And you can actually, at 400x, you can actually count the number of chambers or locules. And it should look like figure number 5 in plate 1. Okay? And actually, this view that I have here is very similar to figure 4 in plate 1, where it shows both the multilocular pores and a quinquelocular pore surrounding near it. Okay, the other character I want to draw your attention to that's also included in that key is the duct type. It mentions oral collar ducts abundant. So what I have projecting on the screen right now should correspond to figure 8 on plate 1, which are the oral collar ducts. Okay. Now, they are obviously tubular in structure. The interior part is usually darker, and in the view that I have on the screen right now, this is actually the body wall right here, and you can see here that the duct is actually opening on the body wall. Now, it's a fairly simple opening on the cuticle there. There's not a great deal of structure surrounding it. So that's a fairly simple type of duct that we call the oral collar type. And if you move around on your slide a little bit, you can usually pick up, in this case, there are of a couple of different types. So in this image here, for instance, projected on the screen, I have a larger oral collar here, and then a smaller one. So now I have two distinct size classes of oral collar ducts. So that's the one that corresponds to figure 8. Okay. While we're in this region, I'm going to go down in magnification and move to the leg. In this case, I'll go to the third leg. You can choose either the right or the left leg. The tip, I want to go to the claw. That's at this view is at 20x, but I'm going to need to go to 40x to see it more clearly. Okay, now I've got this view here. This is the claw. Okay. Also associated with the claw, these structures here, those are called digitules, and they aren't particularly relevant in mealybug taxonomy. But the thing that is relevant is on the interior curvature of this claw, you will see that there's a bump there. You can focus in and out to get it. It's very small. That's called the denticle. Okay? And the presence or absence of a denticle is often characteristic of genera, but also characteristic of species. Okay? So the presence of this character here, when I contrast its state with what we would find for the next part of the couplet, for the pink hibiscus mealybug, is absent. It would just be a smooth curve on the inside of that claw. Okay, so now we have another positive character for Phenacoccus here. Okay, and we've done the quinquilocular pores. Now we're going to go try to find the dorsal seeding. And that corresponding illustration for that one in the plate is plate 1, figure 2. Okay. Now for the an examination of the dorsal seeding. As you can see, if you pull back to 20x or 10x, the surface of the mealybug is covered with hairs of various types. These, for instance, here, these are long, simple flagellate setae. Okay, they're going to be common on almost all mealybugs. The density of those setae can vary, but typically those long flagellate setae are not that important for running through keys. But for this genus, an important character, it'd be hard to see it at that, so we'll go up to 200x. I'll focus in and out. Okay, I'm looking at there we go. Now I've got the dorsum. Okay. All right. And I can tell that I'm on the dorsal side because in the same view I have a Cerarius, which in typical mounts will, even though they're really on the lateral margin of the mealybug in life, typically they appear in so that's another way that you can tell that you're on the dorsal surface, is if you can bring into view the osteole, then the characters surrounding it are going to be dorsal surface characters. The osteole here, this is a posterior osteole. It's a paired structure, and it can be present also in the on the anterior, just adjacent on either side of the mouth parts. The most obvious way to pick up an osteole is to look for this heavily sclerotized curved area here. It's going to be kind of lip-like, okay? And in reality, it's sort of a protrusion, a paired protrusion on the dorsum of the body that has a concentration of pores, the trilocular type, and is a little bit more sclerotized. So they're another good landmark character for regional morphology. Going back to our setae now, if we actually look here on the osteole, right there is the seta that we're looking for. Now I'm going to try to go up to 400x here. Okay. And you can see that its overall shape, where am I here? Right there. Sort of has a kind of a flame shape to it. Kind of has a little bit of a bulge at the base, then tapers out. Okay, and this is a very common setal type for the genus Phenacoccus. Okay, and they are sort of broadly distributed around the body. Now, the other character that I want to emphasize to you is the distribution of the multilocular pores. Here we have them back in focus again on the. Let's see if I can get my focal planes established. There we go. All right. In this view here, I'm bringing one of the surfaces into focus with paying attention to these multilocular pores, and then I'm going to go through the body, and then I'm going to pick up a whole new set of multilocular pores in some other regions of the body, but close by. So now what I've done is I've essentially proved to myself that I have multilocular pore distribution, at least on the posterior of the venther, in both the dorsum and the ventral surface. Okay. So that's another positive key character for the Phenacoccus. All right. So we can try to determine what the situation is with the anal bar. For the anal bar, we're going to have to go to the anal lobe, which is here. In all but a few genera, the anal lobe will be reasonably distinct, even if it doesn't have a readily identifiable Cerarius. There's not that many trilocular pores. The Cerari and Ceti are absent or feeble. It'll still be relatively lobe-like, though it may not be extensively lobed. But if I focus in through the depth of this anal lobe, I really don't see anything other than the sockets for the Cerari and Ceti, trilocular pores surrounding it, some of the dorsal Ceti, okay, and evidence of, on one of the surfaces there, of the oral collar ducts. The pink hibiscus mealybug would actually have an anal bar there, and we'll have to see that in a different slide. And it's also a good idea to try validate that you have an adult specimen for the purposes of the key. This structure here is the vulva, and you can tell that it's the vulva. It's got a very distinct modification of the cuticle. It's going to be very pleated-like, almost like it's going to have a drawstring that can pull it tight. Okay, it's restricted to the venter, just before the 8th segment. So it's also a good regional landmark that you're around the 8th segment. Okay, and every adult female will have one of these, but if it doesn't, it is definitely not an adult female. Another thing to bear in mind too is that this is the opening for where either the eggs or the crawlers come out. All right, so this is the opening of the reproductive structures. And for those species that either lay their eggs into a cottony ovisac or protect them somehow in an ovisac as a larvae emerge, that ovisac wax is produced in part by these multilocular pores. So if it's an ovisac producing species, it's going to have multilocular pores, and they're going to be at least present around the vulva. Okay, so if you want to look for multilocular pores presence at all, a great place to start is around the vulva. Okay, and indeed, Phenacoccus madeirensis makes a fairly robust ovisac. We're going to move anterior direction now, and I'm going to pull out a little bit on the magnification because I want you to be able to focus in on this. We're going to look at a couple of characters now that are specific to the species madeirensis, the Madeira mealybug. I want you to go to the region just a couple of segments posterior to the origin of the last pair of legs, in the middle on the venter. This other prominent structure here is the circulus. Circulus is common in the majority of species, although it is something that can be absent, and in some cases in some species it can actually be multiple, so there can be 2, 3 or so circuli. Those are not that common and very distinctive when you see it. Now, if you've got that in focus at about 10x, go to 20x or so, and I want you to be able to compare this. I guess it's not an illustrated one because it's not always easy to capture as an illustration. It's got kind of a little bit of a lobe-like structure that's kind of flattened down here. In reality, this thing actually protrudes off of the venter of the mealybug. But when it's slide-mounted, the lobes that are protruding out kind of collapse. So this actually, in a really good preparation, almost looks like a mushroom that's been cut in cross-section. It can range from anything that's a small circle to a reasonably large circle to a circle that's been divided in the middle. So actually, the abdominal segmental line will go through it, in which case it's a divided circulus, and that's important at genus and species as well. So there's a significant amount of variability in its shape, and that can all be assessed when running through the key. Now I want to continue forward a little bit because there's another character that I always look for when I have something I think is a Phenacoccus madeirensis. I'm going to pull out here in magnification to 10x for a moment, and I'm going to go more anteriorly on the body and try to get the dorsum in focus. The notable quality about this this species, the circulus in this species, it's not always visible depending on the mount, but in a good mount, and actually when, as John was saying, in alcohol, when the waxes come off, you can actually see this shape through a stereoscope. It actually kind of looks a little bit like a mushroom that's been in cross section. So there'll be almost a central shaft, and then there'll be almost two wings that come out as curves a little bit. Okay. So what I want to do is go up on the mealybug to around below the mouth parts, kind of in the middle a little bit, and then go up to 200x. And what I want to look for is the sockets, the cedal sockets for the Cerariancidae. Now, Cerariancidae do not have to be restricted to the margin in the form of a Cerarius. The shape of the cedia and the structure itself can actually be distributed over the dorsum of the body in other taxa. So this, for instance, I'm trying to pick up evidence of these, either the socket or the cedia itself, but actually more on the midline of the body, not just the margins. What's going to help me decide that that's the structure I'm looking for is not just the fact that I've got the big socket there, okay, here, but also that I've got a few trilocular pores surrounding it too, okay? Other ceti, just the standard dorsal cedia type that we've looked at, around here for instance, don't have any particular concentration of trilocular pores. And the flagellate ceti, where they're found, don't either. But in this species, those Cerarian type ceti there will have trilocular pores. So that's how we're actually able to establish if this is Phenacoccus madeirensis, the Madeira mealybug. And there, the corresponding illustration for the plate is figure 6, plate 1, figure 6. The flame-like Cerarian ceti, a bit larger than the dorsal ceti, the very evident socket, and then the trilocular pore surrounding it. One of the things that I try to use if I'm having trouble finding the denticle, and I think it's supposed to be there, is if you've got around 400x is the least you're going to need in order to really properly discern it. Is kind of focus in and out on the edge of that claw. You're less likely to see the actual structure than changes in the light quality where the denticle is, because it's actually going to, the light's going to be bouncing off of it a little bit, and it's going to change the light a little bit. So you may not see the structure, but you'll see that there might be changes in the way the light's behaving. It's a kind of color difference. And there are genera that have species in it that will have the denticle, and then there are some other species in that genus, and it's very clearly that genus where it's not there. So it's a character that can vary at the level of species within a genus. But if you see a combination of characters, 9 antennal segments, denticle on the claw, quinquilocular pores, and flagellate, the flame-shaped ceti, those are all characters that are fairly consistent within the group of genera that we call the Phenacoccini. And there are a number of genera that, so if you've got an oddball genus somewhere that you haven't quite seen, if you go through that kind of suite of characters, that might place it a little bit more closely at the tribal level.